Proteins are these incredible little machines that basically do everything in our body. Examples of proteins there's a protein called hemoglobin that transports oxygen from your lungs to the rest of your body. You have proteins in your body that break down food when you eat it. Muscles are composed of proteins that help your muscles contract. Insulin is a protein. And so what protein design is trying to learn how to make new proteins that do things that maybe we don't see in nature. The reason why this is really important is because then you can use these design problems to solve a lot of interesting problems. What AI has basically done is just made protein design more reliable. And so we can make larger things, more complicated things. And so, for instance, one thing we're working on right now is a new vaccine for dengue virus, where we're trying to create this large structure that basically resembles the virus, but it isn't a virus. It doesn't have the ability to replicate or anything. And to do that, we're having to design this protein that's basically a ball within a ball. And we wouldn't have been able to do that before AI. AI has just made it more predictable what the outcomes will be.
So I have the opportunity to make some of these AI models and train them from scratch in addition to using them. And that's really interesting because you see where these models can be really effective, and you also get a good sense of what their limitations are and what we have yet to figure out. And they've been incredibly useful for making our jobs a lot easier and allowing us to work more efficiently and work on problems that are more ambitious than we could do before. I'm hoping that we can continue to come up with interesting ways to apply these models. There are some projects that we're working on that wouldn't have been possible 5 or 10 years ago. It's a very exciting time in the field, and the AI tools that we're working with and developing are a big part of that.